everyone. Welcome you all to the chemistry class. In the last class, we were studying about the acids and bases. We have covered the definitions of acids, bases, and we have also studied about the indicators. In this session, we are going to study the chemical properties of acids and bases. Okay, let's get started. Okay, first let us study the reaction of acids. That is, the first reaction will be with metals. Okay, how do acids react with metals? When metals reacts with acids or acids reacts with metals, what happens? There is a formation of salt and hydrogen gas. There is a formation of salt and hydrogen gas. Okay, let us see this reaction with the help of an activity here. Okay, see this picture. You can see the test tube here. Take a test tube. In it, add 5 ml of dilute sulfuric acid to it. So we are going to study the reaction of acid with metals, right? So we have taken the acid, that is dilute sulfuric acid, in this test tube. Then add zinc granules to it. Zinc is a metal. Okay. What happens? The reaction proceeds. Zinc reacts with dilute sulfuric acid. What happens? There is a liberation of gas here. That gas is collected in this tub, small tub. Okay. Then you can see here the bubbles are formed, which indicates that there is a formation of effervescence of gas. Okay. This is due to the formation of hydrogen gas here. Okay. We will also test how this gas is produced. First, let us write the reaction, write the equation for the reaction. What has happened here? Here, zinc metal has reacted with dilute sulfuric acid, dilute H2SO4 to form salt. Okay, which salt is formed here? It depends on the metal and the acid that you have taken. We have taken the sulfuric acid. So, zinc sulfate is formed. Okay, zinc sulfate is formed in this reaction. Then there is a liberation of hydrogen gas here. Okay, what has happened in this reaction? Here, zinc has displaced hydrogen from this acid to form zinc sulfate salt, and there is liberation of hydrogen gas here. Okay, this is zinc sulfuric acid. There is a formation of salt, that is zinc sulfate, and this is hydrogen. Okay, what has happened here? Zinc granules reacted with sulfuric acid to form salt and hydrogen gas. Then, when this gas is produced, it is colorless. Okay, how do we find that gas is of hydrogen? What we need to do is, we have to bring the burning candle near this gas. Okay, once the gas is evolving during the reaction, we have to bring it near the gas. What happens if it is a hydrogen? Then the gas will burn with the pop sound. So this is called as pop test for hydrogen. See here, you can see here, this is a candle. Okay, this is a candle and this is a gas that is evolved. Once it catches fire, that is, it will burn with a pop sound. This is called as pop test for hydrogen, in order to identify which gas is evolved, whether it is hydrogen or not. Okay, then let us see a few more examples here. Magnesium reacts with dilute HCl, dilute hydrochloric acid to form salt, that is magnesium chloride. As I have already said, that the type of salt that is formed depends on the acid and metal you have taken. Okay, here magnesium has displaced hydrogen to form the salt magnesium chloride, and there is a formation of hydrogen gas here. Okay, this is magnesium. It has reacted with hydrochloric acid to form magnesium chloride, and there is a formation of hydrogen. So in general, we can say that when acids reacts with metals, what happens? There is a formation of salt and hydrogen gas here. So I can generalize this equation as metals or acids reacts with metals to form salt and hydrogen gas. Okay, if you remember this general equation, then you can easily solve the reactions. You can easily write the reactions of metals with acids. Okay, this is a general equation. Then here the question arises that, do all the metals will displace hydrogen? Yes, We have studied the displacement reaction in the first chapter. What has happened here? Here the displacement reaction has taken place where metals have displaced hydrogen from acid to form salts. It is a example for displacement reaction. Now question arises here, do all the metals displaces hydrogen from the acids? No. Only those metals which are reactive, which are more reactive than hydrogen will displace hydrogen. Means will react with acid to form saltine hydrogen gas. But the metals which have low reactivity than hydrogen will not react with acids. Okay. We have also studied this activity series in the chapter 1. As you go down, the reactivity will decrease. Okay. The metals which are placed above in this series above the hydrogen are reactive than hydrogen. These will react with acids to form salt and hydrogen gas. But what about the metals that are below hydrogen? For example, if I take Ag plus H2SO4, whether the reaction occurs? No, the reaction will not take place because it is less reactive than hydrogen. Okay, you have to remember this activity series because it is applicable for displacement reaction that you have studied in chapter 1. It is applicable here also when you study the reaction of metals with acids. Okay, it is also applicable for metallurgical process. So you have to remember this activity series without miss. Okay, so overall you have studied that when metals reacts with acids they form salt and hydrogen gas. Then how do you test the presence of hydrogen gas there? By bringing a burning candle near the gas. If it burns with a pop sound, then the liberated gas is of hydrogen. Okay. Now let us move to the next part, that is how do bases react with metals. Here one interesting thing is not all the metals react with bases. Only few metals like zinc and aluminium will react with bases. Let us see how do they react. Zinc reacts with base, that is strong base, that is sodium hydroxide, to form sodium zincate salt plus hydrogen. Okay, only few metals that is like zinc and aluminium will react with the strong base like sodium hydroxide to form salt. It is sodium zincate. Sodium zincate is slightly soluble in water. Okay, so not all the metals will react with base to form salts like this. Like this, we have to remember that not all the metals react with bases to form salts. So you have to remember this particular reaction as this reaction takes place. That is zinc reacts with strong base, that is sodium hydroxide, to form sodium zincate, and you have to remember this name also, sodium zincate. It is a salt. Then let us solve some of the questions here. Complete the following reactions. Iron plus sulfuric acid. This comes under the reaction of metals with acids. Okay. Metals reacts with acid to form salt and hydrogen gas. We have studied now only. So the salt formed is iron. So there is a formation of iron sulfate and liberation of hydrogen gas. This is iron sulfate. Then reaction of copper with hydrochloric acid. Here also copper being more reactive than hydrogen, it forms copper chloride. Okay, this is copper chloride. When equations like this or reaction like this are given in your examination, you should remember the activity series. If these metals are more reactive than hydrogen, then you can easily write the equation as like this. And if it is very less reactive than hydrogen, then the reaction will not take place. Okay. Then let us read the next question. What happens when dilute hydrochloric acid reacts with magnesium ribbon? This is also a reaction of metal with acid. Okay, we know that when metals are made to react with acid, they form salt and hydrogen gas. Okay, magnesium metal reacts with dilute hydrochloric acid to form the salt, that is magnesium chloride. As I have already said that the type of salt means which salt is formed depends on the acid and metal we have used. Okay, here there is a formation of magnesium chloride, liberation of hydrogen gas. So this is the reaction that takes place. Okay, so we have seen that when metals reacts with acid, they form salt and hydrogen gas. One more thing you might have observed in your home, that pickles are not stored in metal containers. Okay, have you observed in your home? always the pickles are stored in plastic or glass jars. Okay, why? Because pickles contain acid. Okay, if lemon pickles are made or tamarind is added to it or mango pickles are made, then all of these contain acids. Okay, so when these pickles are kept in the metal containers, what happens? There is a formation of reaction, that is salt and hydrogen gas are formed, which is toxic in nature. Okay, because of which it can harm our body. So we will not usually use the metal containers for storing pickles. It may be asked in your examination that why the pickles are not stored in metal containers. You have to write that the reaction of acids takes place with metal, so the toxic substances are formed there which can harm our health. So the pickles are always stored in either glass jars or plastic containers. Okay. Now we are going to study the reaction of acids with metal carbonates and metal hydrogen carbonates. What are metal carbonates? Carbonates of metals like sodium carbonate, calcium carbonate, magnesium carbonate. These are carbonates of metals. Carbonate of sodium metal, carbonate of calcium metal, carbonate of magnesium metal. These are called carbonates of metals. Okay. Now we are going to see the reaction of metal carbonates and metal hydrogen carbonates with acids. What about metal hydrogen carbonate then? They are also called as metal bicarbonates. Okay. NaHCO3. Example, this is example for metal hydrogen carbonate, which is also called as sodium bicarbonate. It is called as sodium bicarbonate. Means metal hydrogen carbonates are also called as metal bicarbonates. Okay. Now we are going to see the reaction. Let us understand this with the help of activity here. You can see the test tube here. In this test tube, we have taken the dilute hydrochloric acid, which is acid. Okay, then we are going to add metal carbonate and metal hydrogen carbonate into separate test tubes. Then we are going to observe the reaction. Okay, once this reaction takes place, there is a formation of gas here. Again, this gas is collected in test tube for testing which gas is liberated. We will come to it little later. Okay. Right now, let us understand this with the help of example. Okay, let us take the example of sodium carbonate, which is given in your NCERT text also. This is metal carbonate, reacts with acid, HCl, hydrochloric acid. What it forms is, it forms salt, carbon dioxide and water. By sodium and chloride ions, there is a formation of salt, and also there is a formation of carbon dioxide and water. Okay, this is the reaction that takes place when metal carbonate reacts with acid. There is a formation of salt from sodium and chloride ions, and there is a double displacement reaction takes place actually, and there is a formation of H2CO3 here. To balance this equation, actually there is a formation of H2CO3 and it eventually breaks down to form H2O and CO. Okay, this is what happens here. This is metal carbonate, this is acid, there is a formation of salt and carbon dioxide and water. So in general we can say that when metal carbonates react with acids, they form salt, carbon dioxide and water. Okay. What about metal hydrogen carbonate? Let us take another example, NaHCO3. It is sodium bicarbonate, that is sodium hydrogen carbonate. This reacts with acid to form again salt, carbon dioxide plus water. You can see in both the reaction the products formed are same. Only difference is the amount of hydrochloric acid that is being consumed. In this reaction, only two molecules of hydrochloric acids are consumed, whereas here only one molecule of hydrochloric acid is consumed. Okay, it is metal hydrogen carbonate. This is acid. Here again there is a formation of salt, carbon dioxide and water. So you have to remember in both the cases there is a formation of salt, carbon dioxide and water. Okay. Then as I have already said that once the reaction takes place, there is a liberation of gas. Okay, we have seen here there is a formation of carbon dioxide gas. But by seeing the gas, it is colorless. We cannot understand which gas it is. So we have to test it. How can we test the presence of this gas? Yes, we have a test to test the presence of carbon dioxide in a reaction. We test carbon dioxide gas by passing the gas through lime water. Okay. Let me write the reaction what happens there. When carbon dioxide gas is passed through the lime water, that is calcium hydroxide, it turns lime water milky. Because it is not soluble in water, there is a formation of calcium carbonate there. Okay. Test for carbon dioxide. When CO2 gas is passed through lime water, it turns lime water milky. Okay, what the reaction that takes place? This is lime water, calcium hydroxide. When carbon dioxide gas is passed through it, there is a formation of calcium carbonate there. It is not soluble in water, because of which it turns the lime water milky. It is white precipitate. This is calcium carbonate. Because of the formation of this calcium carbonate only, it turns the lime water milky. Okay. This is the test for carbon dioxide gas. Here you can see that the lime water is taken in this test tube, and whatever the gas that is being liberated is collected in this test tube. So that carbon dioxide gas reacts with calcium hydroxide, that is lime water, to form calcium carbonate. Okay. So by seeing the white precipitate, we can understand that the liberated gas is carbon dioxide gas. One more thing that happens here is, when large amount of, means excess of carbon dioxide gas is passed through the lime water, what happens? It will react with calcium carbonate to form calcium hydrogen carbonate. Okay. When excess of carbon dioxide gas is passed through it, there is a formation of calcium hydrogen carbonate, which is completely soluble in water. Okay. This is completely soluble in water. Again, the lime water which has turned milky becomes colorless, because all the calcium carbonate that has formed again reacts with carbon dioxide to form calcium hydrogen carbonate. This is soluble in water. Okay. Aqueous means it is soluble in water. This is calcium hydrogen carbonate. So the question may be asked in your examination that what happens when excess of carbon dioxide gas is passed through the lime water. You have to remember both these equations. Okay. When first carbon dioxide gas is passed through the lime water, there is a formation of calcium carbonate here. Again, when excess of carbon dioxide gas is passed, there is a formation of calcium hydrogen carbonate, which is soluble in water. So again the solution becomes colorless. Okay. Means it becomes clear. Calcium carbonate is also called as limestone. Okay. It is also called as limestone, and it is available in form of chalk and marbles. All of them contains calcium carbonate. So it may be asked in your examination by taking these names also. When chalk is made to react with excess carbon dioxide, what happens? Then you need to remember this. These all contains calcium carbonate. Okay. So overall what we have learned here is reaction of metal carbonates and metal hydrogen carbonates with acids. So I can generalize the equation as metal carbonates or metal hydrogen carbonates reacts with acid to form salt, water, and carbon dioxide. Yes, this is a general equation. If you remember this general equation, then you will be easily able to write the reaction, the equation. Okay. Let us solve an example here. It is an in-text question. Metal compound A reacts with dilute hydrochloric acid to produce effervescence. The gas evolved extinguishes a burning candle. Write a balanced chemical equation for the reaction if one of the compounds formed is calcium chloride. We have to find out what metal compound A is. Okay. Okay. We don't know the compound A. It reacts with dilute hydrochloric acid. Okay. To form the effervescence. And they have given a hint that this gas evolved extinguishes a burning candle. Usually we know that carbon dioxide gas is a fire extinguisher. Okay. So one of the products that is formed is carbon dioxide gas, we came to know. Then write a balanced chemical equation for the reaction if one of the compounds formed is calcium chloride. And they have also mentioned that one of the compounds formed here is calcium chloride. So we need to complete the reaction and balance it. Okay. Here you can observe that there is a formation of carbon dioxide gas and there is a formation of salt and there is acid here. So which type of metal compounds react with acid to form carbon dioxide gas and salt? Yes, of course. You are right that metal carbonates react with acid to form carbon dioxide, salts and water. Okay. So there must be water here. Which metal carbonate must be A? Okay. We have got salt from calcium. Okay. Then the metal carbonate should be calcium carbonate. Okay. This is a metal carbonate. When it is made to react with aqueous solution, that is hydrochloric acid, it forms the salt calcium chloride plus carbon dioxide plus water. Yes, this is the equation. You can write the name of the reactants and products. It is calcium carbonate. So the metal compound A is calcium carbonate. The metal compound A is calcium carbonate. Okay. Now we are going to study the reaction of acids and bases with each other. When acids and bases react with each other, they form salt and water. Okay. When acids and bases react with each other, they form salt and water. There is a particular name for this reaction. This reaction is called as neutralization reaction. Okay. This reaction is called as, let us take an example. HCl is an acid. When it reacts with base sodium hydroxide, there is a formation of salt, that is sodium chloride and water. So when acid and base react with each other, acid plus base, they form salt and water. What happens here is there is an exchange of ions takes place that you have studied, that is double displacement reaction takes place. Sodium and chlorine, their ions form sodium chloride and H plus and OH minus ions form H2O. Whatever the H plus ions, they are coming from acid, and OH minus ion of water, they are coming from base. Okay. This is acid, base. They have formed salt and water. This particular reaction where acids and bases react with each other to form salt and water is called as neutralization reaction. Because here both of them nullify the effect of each other. When acid and base react together, acid nullifies the effect of base and base nullify the effect of acid. As they nullify each other's effect, they neutralize each other to form a neutral substance, that is salt. We cannot always say that this salt is a neutral substance. It may be acidic salt, it may be basic salt. We will come across this concept little bit later. Okay, let us understand this reaction with the help of an example. Okay, this is a test tube containing sodium hydroxide. Okay, this has sodium hydroxide in it. What we have to do? We have to make the reaction of acid and bases. Okay, now I am going to add here HCl to it. Before adding hydrochloric acid to it, check the color of sodium hydroxide with phenolphthalein indicator. How does it look? It looks pink in color. When you dip the phenolphthalein indicator strip, or if you add the phenolphthalein indicator solution to sodium hydroxide, it turns pink color of phenolphthalein because it is a base. Okay. Now what happens? Go on adding the hydrochloric acid to it. What happens is there is a disappearance of pink color as you go on adding hydrochloric acid to it. There is a the pink color start disappearing. Okay, in this solution, and there comes a point when it becomes colorless. We know that phenolphthalein indicator, it indicates the pink color in basic solution. Okay, and there is no color in neutral solution. Okay, so again when it turns colorless, go on adding HCl to it. Okay, then it will show colorless because there is no base here, as all the base is consumed in neutralization reaction. Here HCl has nullified the effect of sodium hydroxide and sodium hydroxide has nullified the effect of HCl. So it shows colorless. Then what to do is, Again add some sodium hydroxide to it. Again check the color. Then again it will show the reappearance of a pink color. Then we have added base to it. So this shows that acid and base nullify the effect of each other. Okay. Have you understood how do they neutralize each other's effect? Okay. This is all about neutralization reaction. Okay. You can take few more examples of it. Examples of neutralization reaction. When hydrochloric acid reacts with potassium hydroxide base, it forms salt, potassium chloride and water. And when NaOH, that is base, when it reacts with sulfuric acid, it forms salt, sodium, sulfate plus water. Okay, these are some examples for neutralization reaction where there is a formation of salt and water. The type of salt, it depends on the type of acid and base you have used. Okay, these are also example for double displacement reactions. Next, let us study the reaction of acids with metal oxides. Let us take an example of copper oxide with hydrochloric acid. Copper oxide is a oxide of metal, that is copper. Okay, let us take the example. When copper oxide is dissolved in dilute hydrochloric acid, it forms copper chloride, CuCl2, and there is a formation of water. Initially it was black in color. Copper oxide is black in color. When you add to the solution of, that is hydrochloric acid, what happens? There is a formation of blue green copper chloride, because here it has undergone the reaction with hydrochloric acid to form salt and water. It is salt and this is water. Metal oxide, it is metal oxide, oxide of copper, and this is acid. Here there is a formation of salt and water. Little before we have seen that when acids and bases react with each other, there is a formation of salt and water. Here we have acid, here there is a formation of salt and water. Then what does this indicate? It must be basic in nature. So we can say that metal oxides are basic in nature. So let us write the general equation for this. When metal oxides react with acids, they form salt and water. As this is a neutralization reaction, we can say that metal oxides are basic in nature. Metal oxides are basic in nature. So what we have done here, we have taken hydrochloric acid and we have added copper oxide to it. There is a formation of salt, copper chloride and water. As there is a formation of salt and water, this is a neutralization reaction between acid and base. So here copper oxide acts as base. Okay, then let us see the reaction of base with non-metal oxide. Okay, then what might happen there? Let us see. Let us take an example. Carbon dioxide is a non-metal oxide. Carbon is a non-metal and oxide of carbon is carbon dioxide, that is non-metal oxide. And let us make it to react with base. That is, let us take the example. Calcium hydroxide is a base. Let us make the reaction of base with non-metal oxide, that is carbon dioxide. What it forms? It forms salt, calcium carbonate plus water. This is a base and this is a non-metallic oxide. There is a formation of salt and water here. Can you remember this equation? Yes, we have seen it little before. That is for testing the carbon dioxide gas. There we have seen. It is a non-metal oxide and we are going to make this react with calcium hydroxide, that is base. Here there is a formation of salt and water again. Again, what does this indicates? It is a neutralization reaction where base might have reacted with acid, which indicates that non-metallic oxides are acidic in nature, because here acid and base react to form salt and water. We have base here, we have salt and water. Then this non-metallic oxide must be acidic in nature. So what we came to know is non-metallic oxides are basic in nature, sorry, acidic in nature, are acidic in nature. You have to remember these 2 points. Okay, metallic oxides are basic in nature, non-metallic oxides are acidic in nature. This is all about the reaction of acid with metal oxide and base with non-metal oxide. We have seen the properties of acids and bases and how do they react with other substances. Okay, all the acids behave in a similar manner. Okay, they react in a same way, and also bases also react in a same way. Then all the acids must have some common property and bases must also have some property in common. Okay, let us check what is the common property that all the acids are having and what is that common property that all the bases are having. Let us understand this concept by an activity here. Okay, let us perform an activity. What you have to do is, let us see an activity. Take the solutions of glucose, alcohol, dilute hydrochloric acid or dilute sulfuric acid in separate beakers, then fix two iron nails. You can see in the picture, these are two iron nails. Fix these iron nails on the rubber cork and place it in the beaker. Okay, then connect these terminals to the battery. Okay, then fix the two nails or connect iron nails to the terminals of the battery with bulb and switch. Okay, now you have to take the solutions that are mentioned here, that is glucose, alcohol, dilute HCl and dilute H2SO4 separately. Now switch on the current. First take dilute hydrochloric acid in the beaker and switch on the current. You have to make the observations. What are the changes that you are going to see here? Okay, then repeat the same experiment, that is connect the terminals of the connect the ends of these nails to the terminals of the battery with switch and bulb. Again switch on the current by using the different solution, that is glucose, alcohol, sulfuric acid, one by one. Okay, then make the observation, then repeat same experiment taking different solutions, then make the observations. Okay, make the observation. What happens here when electric current is passed through the battery, that is this circuit is complete now. When you switch on the current, electric current starts flowing. Okay, in the case of hydrochloric acid, sulfuric acid, the bulb was glowing. Okay, the bulb was glowing in the case of hydrochloric acid and sulfuric acid, but it was not glowing in case of glucose and alcohol. What does this indicate? What we have observed here is observation, bulb glows in case of HCl and H2SO4, but the bulb was not glowing in case of glucose and alcohol. Why? Because in order to blow the bulb, what is the necessary condition? That the electric current must flow through the circuit. Okay, for flowing of electric current there must be movement of ions. Okay, when and only when there are ions in this solution, this will conduct the electricity, means the solution will conduct the electricity only in the case that there is a presence of ions there. If the ions are not present here, then the electric current is not supplied to this solution, means the circuit is not complete now. The bulb will not glow at all. In the case of HCl and H2SO4, there is a ionization that has taken place. How? When HCl and H2SO4 are dissolved in water, they form ions like H plus Cl minus. Okay, they have formed the ions. The same has happened in the case of sulfuric acid. Okay, these ions are responsible for flow of electric current, because of which the bulb has glow there. Whereas in case of glucose and alcohol, there is no formation of ions there. Okay, this shows that the acids contain H plus ions, means they produce H plus ions in aqueous solution, which is responsible for their acidic property. Okay, these H plus ions are responsible for acidic property. This we have concluded from the experiment. What about glucose and alcohol? Even glucose contains hydrogens. Okay, it also contains hydrogens, but it will not produce H plus ions. Okay, It will not produce H plus ions. So it has not conducted the electricity, because of which glucose is not an acid, because it will not produce H plus ions. In order to be acid, it must produce H plus ions in aqueous solution. Whatever the characteristic properties of the acid, it is due to the presence of the H plus ions. Okay. You can repeat the same experiment by using basis also, basic solution. When you take here the basic solution in this beaker, then also we see that there is a glow of bulb, means the electric current is flowing through the circuit there. Okay, why does the electric current flow in the circuit? Because they have produced ions. When you take bases like sodium hydroxide, they have produced ions, that is sodium ion, hydroxide ion. These ions are responsible for conducting the electricity. For flow of electric current, we know that there must be movement of charges, or there must be movement of ions or electrons. Here, in case of basis also, there is a formation of ions. Okay, you can take KOH, that is potassium hydroxide, it forms ions. So these bases which produce hydroxide ions, these hydroxide ions are responsible for their basic properties. These are responsible for basic nature. So now we have understood that what all the acids have in common. All the acids produce H plus ions in solution, because of which they show the similar properties, that is they show similar reactions with other metals or metal carbonates in this way. And also all the bases means that are soluble in water. Here we have to take the name alkalis, because we are carrying this experiment in water. Okay, solution of these bases in water. Only those bases which are soluble in water, they produce hydroxide ions. Okay, these alkalis which produce OH minus ions are responsible for basic nature. So they behave in the similar way. So now we have understood what all the acids and bases have in common. Acids produces H plus ions in aqueous solution, and bases produce OH minus ions, which are responsible for their properties. Okay, and also one more thing we have realized, that all the substances that has hydrogen ions are not acids. Okay, we have seen right now that glucose, even though it contains hydrogen, it is not considered as acid, because it will not produce H plus ion in the solution. Okay, only those substances which gives H plus ions in solution will behave as acids. Okay.